Okay, so in this lesson, we're going to be talking about charging by induction. Induction and conduction are different because with conduction, the objects will touch each other, but with inductions, the objects never touch each other. So we have a few examples here. In our first example, we have a negatively charged object and a neutral object. If we bring this negatively charged object closer, some of our electrons are going to move. But remember, it never touches, so it is not possible for these electrons to go anywhere, or these electrons to go anywhere. Let's move over to my example. So I've brought this rod really close to my initially neutral object. Really close, but not touching. What happens is our like charges are going to repel. So these electrons are going to move as far away as possible from these electrons, leaving us with positive charge on this side of the object and a negative charge on this side of the object. It's important to remember that this charge is temporary because as soon as I move this rod away, these electrons are going to disperse again, just like people on a bus. Okay, here's my next example. In this example, we have a positive object and a neutral object. Pause the video. Can you figure out where the electrons are going to go? Are they going to go on the right-hand side of the object or the left-hand side of the object? Pause and try and figure it out on your own. Okay, so what will happen is these electrons will be attracted to the positively charged object. So now we're left with an object that is negatively charged on one side and positively charged on the other side. This is in comparison to our initial object. Oh my, things have moved around. In our initial object, we had a negative charge on the right-hand side because they're trying to escape this, they're repelling. And in our second object, they're actually on the left-hand side because they're trying to move as close as possible. They're attracted. In both cases, they're temporary charges because as soon as I move this object, those electrons are going to distribute throughout the entire object, making it neutral again. Okay, so here's one interesting thing we can do when charging by induction. We have two neutral objects that are touching each other. Well, so if they're touching each other, how does this involve charging by induction, you might ask? If we bring in another object, and let's say it's negatively charged, where will the electrons go? So I'm going to bring in my object really close to this one. Where are the electrons going to be repelled into? Pause the video. Can you predict where the electrons will go? So here's my diagram with no electrons drawn. If we have a mass of electrons over here, then my electrons are going to move as far away as possible in order to properly repel. So we're going to have electrons moving this way. So initially we had 12 electrons, which means I'm going to have 12 electrons over here. So obviously, this leaves one object positively charged and one object negatively charged. But again, it's temporary, unless what I do is pull the objects apart. So if I pull my two neutral objects apart, and I remove my initial negative object, then I'm left with a positive object, a negative object, and my initial negative object. So all of the electrons from this object have jumped into this one. So here's the example here. We started out with 2 neutral. Then we started out with 2 neutral. Then we made the electrons migrate. And then we took our 2 objects apart. What I want you to do is try and do this situation again, this time with a positively charged object. Can you predict what our final objects will look like? Okay, so hopefully you've had enough time to think about it, given that you had the power to pause the video. Now we need to figure out, where are the electrons going to go? Well, if we have an object that's positively charged, they're going to rush towards the object. And so we're going to get our 12 electrons over here, leaving us with an object that is negatively charged and positively charged when we pull them apart. We have one more example to talk about, and that's how induction and grounding can work together. Okay, so here what we have is a neutral object and a negatively charged object. When we bring the negatively charged object over to our neutral object, well, our electrons are going to run away, same as every other example. What I can then do is ground it. And remember, grounding is the process of eliminating excess charges. So this side of the object has an excess of negative charges. If I go and touch it with my hand, and I'm considered a fairly large object when we're talking about a small object, when I touch it with my hand, see here I've labeled it because, you know, I have great drawing skills. I have now allowed for an egress route or an exit route for our electrons. So our electrons can then flow down my hand, which will leave us with a positively charged object. So that leaves us with a positively charged object. Now, this object might still have some electrons floating around. It's important to know that. But in general, it will become more positive than it was initially. And because my little body over here is so big, those few electrons that have joined my body are pretty insignificant. And so my body could be considered as more or less neutral still. So if we zoom out and take a look at our big picture over here, we had our first example, our second example, third example, fourth, and fifth, where we talked about grounding. The important thing to remember about induction is that charged objects don't ever actually touch each other. So this object, this charged object, never touches this neutral object. This charged object never touches the neutral object. This charged object never touches the neutral object. You will notice that our neutral objects start out touching each other, and then we can elicit a charge by pulling them apart. But the charged objects never touch the neutral object.